Hello. In this tutorial, we are going to explore practically what a vector is. We are going to explore lower bound, upper bound, min, max elements, sort, and lambda in C++11. Before starting with vectors, let us look at arrays in C language. To print contents of array, we can simply run a for loop. So this for loop prints the content of this array. We can also print contents using pointers. So P is a pointer of type integer which is holding a address of first element of array. So I can do it like this, dereferencing the pointer, and I can also do it like this, incrementing the pointer itself. Cool. Vectors are dynamic array. This is how we declare a vector. What this line means is A is a vector of type integer. Now to get the size, we can simply do dot size on vector. This is going to give me the current size of vector. Current size is 0. Now since this is a dynamic array, we can push elements into this vector A, unlike this vector primitive type, this vector of primitive type. So in this loop I am going to push contents in this vector. What pushback does is it appends an element at the end of vector. So now the size is going to be 10. Now let us look at different ways of printing. So first way is of course the normal method of printing an array. A dot size this for loop is going to print contents of array. Another method is by using pointers and iterators. Pointers, iterators, one is the same thing. Iterators are pointers pointing to a specific location in a container class, in a object of type container. So a dot begin is going to give me first element pointing to the vector. So let us see what this element is going to be. This element should be a dot veg in. We should get output as 1 as the first element in this vector is 1. So dereferencing this pointer and content is 1. So if a vector is, now let me make this vector of size 5. Let us look at its contents. Okay, so contents are 1, 2, 3, 4, 5. So what a dot begin gives us is 1, 2, 3, 4. A dot begin gives us iterator pointing to the first element of this vector. So after printing like begin, we were able to get 1 in output. But what a dot ends give us is last element pointing, so which is a blank space. So a dot end is going to give us this spot, so we are not going to get anything in output. But if we do a dot end -1, we are going to get 5 as output because A dot end is going to point over this location. Subtracting -1 is going to get us this location, last location. So this is going to point to the fifth element. As a result, we get output as 5. So let us just use this method for printing. For int I equals to 0, I is less than a dot size, I plus plus, cout, dereferencing a dot begin plus I, just like in case of pointer we did. In order to make a pointer, that is to get an array, we need to write this statement to make an iterator. Let me name it as it, and it is going to point to a dot begin. This statement is exactly same as this statement, making an iterator pointing to the first element. So to print, I can run a loop. So for till the time it is not equals to a dot end, it plus plus, cout dereferencing of this iterator, and I get this output. Now this is a really long statement. We can use a new feature by using auto keyword. Auto keyword reduces the type of declared variable from its initialized expression. So what does it mean? It means if I do auto it equals to a dot begin while it is not equals to a dot end, dereferencing this iterator and iterator plus plus, this is also going to give me the same result. So this statement and this statement are same. So this is another method of printing. We can also use for auto in C++11 onwards. So for auto I in A, so iterator pointing to the first element of A, and this loop is going to run till the time iterator it is not equals to a dot end. In this case, we do not need to dereference this, so we can simply cout I. This is another method of printing. Okay, so we have seen different ways of printing and we have seen what iterators are. Cool. Now let us look at various types of constructors which are there in vectors. So if you see, I have 10 overloads over here. The first overload, if I type something over here, is going to be denoted as size. So if I declare vector with size 9 and I print elements in it, I'm going to get output 9 times 0 because initialization is by 0. If I add another argument as 8, I get all elements initialized as 8. Now let us make a 2D vector. Vector of int. Let me name it as mat, which means matrix. Matrix the n is the row number of rows is going to be 3. Each row is going to contain a column with elements of size 4, and all 4 elements are going to be initialized with 5. Now let us print this. For auto I in A, oh, I have named this as matrix M. For auto J in I, cout J, cout ender. So I have 3 rows, 4 columns, and every element is initialized with 5. Cool. I can also initialize it with -1. Okay, so now let us use vector on a user defined data type. So we can use vectors using class and structures. Let us use structures. So I have a struct, which can also be called as a class. Class and structure are almost same thing. In structure, everything is private, publicly inherited. So string name and roll number. Let me also give some constructors. Student, default constructor is name, no name. Roll number is default going to be 0. Okay. A parameterized constructor, name is going to be this dot name, and roll number is going to be roll number. Cool. Now let us make a vector of student A with size 5 for auto I, that is every elements in I, iterator in I, cout I dot name, I dot roll, enter. So this is going to print contents of these 5 elements. So by default constructor, I'm going to get no name and 0 in 5 lines. Cool. So let me do it like no underscore name and \\t. Cool. Okay. So let me just give initialization. A0 is student with name ABC with roll number 9. A3 is a okay. Let me just copy paste this. Cool. 0 1 2 3 4. Roll numbers in random order 9 8 0 1 10. Let it be 10. Okay, cool. Now ABC BCD XYZ XXX AXY. Cool. Now let us print. Okay, so now I want this to be in sorted order. Okay, like sorted order is you're going to take time to understand. So let me just copy this. Okay, we are going to come back to this. Let us look at first different functions to get it better. Now over here I have declared a vector with some random numbers 38, 69, 45, 3, 4. Indexes are 0, 1, 2, 3, 4, 5. Let me just put a small element over here, 3. Okay, cool. Now last index is 6. Now we have another feature in C++ 11 onwards with called max element function. It has also 4 overloads. You can see failure 1, failure 2, forward iterator 2, forward iterator with a custom comparator function. We shall take a look each of them. A dot begin, so starting range, starting iterator. A dot end, and it takes a compare, so I'm not going to give a compare. It is going to give me a iterator, so let me write auto it equals to this. So maximum element in this case is at index 2 with value as 69. So while iterator is not equals to a dot end, cout it, I need to dereference this it, add some space and do it++. So what have I written? This line is going to give me an iterator pointing to the largest element in this vector. So it is going to give me iterator pointing over here. Let me press Alt and select. Okay, so it is going to give me iterator pointing to this location. And by dereferencing this location, I'm going to get 69. So this while loop is going to run till the end of array is reached. So it is going to print 69, 0, 45, 3 and 4. Similarly, I can also use min. So minimum in this case is 0. So it is now this loop is going to print 0, 45, 3 and 4. Cool. Now the problem is, suppose I don't want to get this iterator. I want to get its position. So I can simply do subtract a dot begin from there, and okay, so let me just first control Z, control C, control V, int. This one is going to be position minus a dot begin. So what this line is going to, this line number 26 is going to do is, it is going to give me the position of minimum element. So minimum element is going to give me iterator pointing to 0. Subtracting a dot begin is going to give me 3 as output. So let me comment this. If I am going to write cout pos, so I should get 3. Cool. If I'm going to do a max over here, then I should get 2. I can also do boxing and unboxing. So a of pos, pos and A of position is going to give me position 2 and element at 2 is 69. Cool. So this is how we get. Now if I want to just print the maximum element, okay, control Z, control C. I can also do it like, okay dear. Now since this is giving me iterator, minimum element or maximum element is giving me iterator, so if I do a dereferencing sign over here, I'm going to get 69 as output. Cool. So now you understand how can we use max function, min function, minimum element function, maximum element function. We can also give a custom compare function, which we are going to see in a few minutes. Okay. Now let us jump to first another function, because this part is going to take time. Another feature, let me just remove comment. We can also use sort function in this. Again, sort also has few overloads. If you take a look, then sort has 4 overload. 1, 2, 3, 4. Random access iterator first, random access iterator last, and compare function. So let us give sort function iterators. A dot begin, A dot end. For auto I in A, C out I, add some spaces. For auto I in A, C out I, add some spaces. Just break a line. So this function is going to, this for loop is going to print these elements. Then sort function is going to sort these elements in ascending order. So output is going to be 0, 1, 3, 4, 38, 45 and 69. And this finally prints the output. Cool. Now let me introduce a comparator function. What compare function does? Bool, in order to give like, how are we going to give this compare function? We want to custom sort this. So we make a function compare full comparator function. It takes two things. It takes integer a and integer b. It returns a which is a greater than b. So if this statement is true, then a is going to be ahead than b in its order, sorted order. So if I'm going to give this compare function, now this array's element is going to be like one by one going to be evaluated using this compare functions. So suppose a is 1 and b is 38. So 1 is greater than 38. This is going to be false. So b is going to come ahead of a. So 38 is going to be ahead of 1. So this, control C, C out enter, sort function, this time using compare function, and then again this. Okay, so first we sorted them in ascending order, then we sort them in descending order. So this is how we used the compare function. Now let us okay, so now let us jump over here, remove comments. Hmm. Okay, so this is the output. Now we want the roll numbers to be in ascending order, so students to be sorted in ascending order of their roll number. So compare function takes two arguments now, student A, student B, return A dot roll number is less than B dot roll number. If this is, then return true true, else return false. We can even skip this because this is going to return true or false accordingly only. Sort A dot begin, A dot end, compare function. Okay, first let's see what is going to be output if we are not giving any compare functions. So it raises an error, no match for less than sign, which means that our program does not know which students to come first. So we must give a compare function for a user defined data type. Okay, so let me print this again. Cout enter. Cool. Okay, so earlier roll numbers were not in sorted order. Now the roll numbers are in sorted order. So this is how we use compare function. You can observe 0 is AXY, 0 is AXY. So elements are being swapped. Okay, so now next I wanted to discuss lower bound and upper bound. Okay, so let me comment this out. We are going to again come back to this when we are going to learn about lambdas. Okay, vector of int a is a random elements. Okay, let me do a random elements also which is going to be repeated. For auto I in a, cout I. Let us look at contents. Okay, so contents are not in sorted order. Now let us sort this. Sort a dot begin, a dot end, and we get this in output. Okay, right after this, cout enter. For int I equals to 0, I is less than a dot size, I plus plus, cout I. This is just to get the index. Control C, cut, backspace. This is our a of I, and this is our indexes. Okay, so you know, after sorting, this is going to be the final values and their corresponding indexes. Just a second, I have two zeros. Okay, yes. So now let us look at lower bound. Lower bound has four overloads: forward iterator, backward iterator, compare functions, failure 1, const type 2. These are generic programming methods. So what lower bound gives us, it gives us iterator pointing to the first element of target. So it takes a minimum of two elements. Okay, a dot begin. Let us give them iterators: begin iterator, ending iterator, and target. So for target, let me give 2. Cool. So it is going to give me iterator vector of type int iterator it equals to this, while it is not equals to a dot end. Cout dereference this it plus plus. So let us expect what the output is going to be. Lower bound is going to give me the first instance of 2 in sorted order. So after sorting, this is going to be the order. So first instance of 2 is this. So what this while loop is going to print is 2238899. Let us see. As expected, we can also skip this cumbersome statement by using simply a auto keyword. Now if we want position, I can simply subtract a dot begin auto pos. Now here auto keyword is going to assign pos as an integer. So okay dear, cout position element at this position. So this is going to give me position as 3, element at that position as 2, 3 and 2. Now 4 is not there in this array. So now let us see what is happening, what is going to happen if I search for 4. So first instance of 4. So 4, since 4 is not present, it is going to give me instance of this pointer pointing to this. So position, because here we are looking for position, so it is going to give me position of this 8. So our output is going to be 6, and a at position 6 is going to be 8. So 6 and 8. Cool. I can simply dereference this and skip this begin and simply use this as cout. This is going to give me 8. What this line means is a lower bound on 4. A lower bound on 4 means first element, first instance of that element, and since 4 is not present, so it is going to give me iterator pointing to this location where 8 is present. Dereferencing that, I get 8, and if I am not going to dereference and minus a dot begin, then I'm going to get 6. Now let us see what upper bound does. Upper bound on let us do upper bound on 8. So upper bound on 8 gives us first element which is strictly greater than target element. So here our target element is 8. So first element strictly greater than 8 is 9. So this is going to give us position of 9, first instance of 9. So we are going to get 8 as output. And if I skip this and dereference this, then I get 9. So we have discussed min element, max element, sort functions, how to write custom custom compare functions. We have seen lower bound, we have seen upper bound. We have also seen vector initialization, size, size plus default. Okay, so we need to see another. Okay. So what we have skipped is for int I equals to 0, I is less than a dot size I plus plus, array of I is going to be array of I. Array of I is going to be I plus 1. So I am going to get indexes starting from 1. Okay, another thing, what this statement is doing, you already know. So here auto keyword evaluates I as integer, so this is also going to work. Cool. So what I was telling is we can declare a vector. Let me give it size as 10. We need a vector b from we need a vector b which is exact copy of a. So if I do it cout for auto I in b, cout I'm going to get elements of a, which is 1 2 3 4 5 6 7 8 9. So now we have seen if I do a dot something some number, then it is going to mean size. If I'm going to do a dot two numbers, then it means size and default fill. If I'm going to give its forward itr and end iterator, then it is going to give us, okay, we have not seen this one, right? If I'm going to give us a and another vector of type b, and if type of a and b matches, then vector a is going to be exact copy of vector b. This is what I have demonstrated over here. So now let us look at this one, iterator fill. So b dot begin, okay, vector b is going to be initialized from b dot begin begin plus 1. So it is going to skip the 0th element. A dot begin plus 4. So 2 3 4 as an output. A dot begin plus 4 excludes this end element. So contents were a was 1 2 3 4 5 6 and so on. A dot begin plus 1 means from 2 onwards, and a dot begin plus 4 means that I need to end before this 4th. So I need to end this before 5th. Okay. Output was 2, 3 and 4, right? Cool. 2, 3, 4 and 4. So indexes are 0, 1, 2, 3, 4, 5. So we need to end this before 4. So before 4 and start from this. So contents were 2, 3 and 4. This was the reason for that output. Okay, now we have seen this. Now we have also gained a lot of experience from this. Okay, now let us again jump back to our student class structure. Okay, mm, now suppose, okay, let me introduce another thing. Marks, roll number, and default marks is going to be 0, int roll number, comma, int marks, roll number, comma, marks is going to be marks. Cool. Okay, so first parameter is roll number. Roll number cannot be same, so roll number is going to be 2. I need to give them marks, so let us say it scored 10 marks, this one scored 13 marks, this 2 scored full. Okay, this guy scored 7 marks and this also got full. Okay, so now I need to sort students according to their marks. So return a dot marks greater than b dot marks. So the now our output is going to be the person with highest marks and then slowly decreasing. Okay, I haven't printed marks there. Mm, I dot marks. Cool. Okay, cool. Control C, Control V. Okay, so this was unsorted list of students with their roll number and mark. Now we have students with their increasing roll number and mark. Now over here you look at a problem. Triple X and AXY scored same marks as 15, but they are not in their order of roll number. So according to their roll number, if marks are same, we need AXY to be greater, AXY to be above triple X. Why? Because his roll number comes first. So how are we going to tackle this problem? An easy way is if a dot marks is not equals to b dot marks, return a dot mar marks, the person with highest marks, so the person with highest marks, and b dot marks. Else we are going to return a dot roll number, whose roll number comes first, b dot roll number. What error is? Student has marks. Cool. So now you see the output. Commenting this out. This was our previous output. AXY was coming below, and this is our new output. Students are sorted according to their mark. If marks are same, then they are sorted according to their roll number. Similarly, you can add multiple parameters over here. Okay, now let us discuss something about lambda operations. Since I Since you might be starting with competitive programming, so you might need to uh, get all these jargons. So what are lambda functions? So this exact logic, okay, compare, compare, compare. I have changed this name and I have made another name, another function. Return type is going to be auto. This is how we declare a lambda function. This part is known as capture. Hmm? This part is known as capture. It can be blank. We can have ampersand over here, or we can have equals to over here. I will explain this later. As in this example, this is empty. Capture is empty. So a compare function takes students A, student B, and this is how we declare a function, anonymous function inside main method. Ends with a semicolon. Cool. So this is going to give us the same output. Just a second. Com was not okay. Okay, same output. Okay. Another example is Control C. Let me make another just for practice. Auto print student, print student. This does not captures anything. It takes a student A and prints this. Cool. So I can simply write print student I, sort, and again here print student I, same output. Okay, I was not declared. I know I was not declared, so I need to replace A. What's the problem? Expected. Okay, ends with a semicolon. Cool. And this is how we use lambda